Welcome back to my tutorial channel. Daniel's here, and today I'm going to continue on topics 8, hypothesis testing. And the test I want to introduce today is one proportion z-test. So for one proportion z-test, I must show you first when to use the test. And I'm going to show you two methods to perform a one proportion z-test, the critical method and the p-value method. So first, when to use one proportion z-test. Let's look at this situation. How cool is Facebook? In a recent Gen X to Z American college student survey, 90% of female college students rated the social network site Facebook as cool. The other 10% rated it as lame, assuming that the survey was based on a sample of 500 students. A marketing executive at Facebook wants to advertise the site with the slogan, "More than 85% of female college students think that Facebook is cool." Before launching the advertisement campaign, he wants to be confident that the slogan is true. Can he conclude that the proportion of female college students who think Facebook is cool is greater than 0.85? So in this situation, we use a sample to make inferences toward the population, and the parameter that we are interested in is the population proportion, the proportion of people from this population who believe that Facebook is cool. And we use a sample of 500 students. So one proportion z-test is a test used when we want to test a population proportion, and when these assumptions are met, NP is at least 10 and N times 1 minus P is at least 10. So we see here, remember that the central limit theorems for proportion say that when NP is at least 10 and N times 1 minus P is at least 10, the sample proportion would follow approximately normal distribution, would mean P and the standard deviation square root of P times 1 minus P over N. So basically, hypothesis testing is to make use of the central limit theorem. And to perform a one proportion z-test, we have two methods, the critical value method and the p-value method. For the critical value method, the test statistic is the z-score of the sample proportion, because we are interested in the population proportion, and the best estimate for the population proportion is the sample proportion. And by central limit theorem, when NP is at least 10 and N1 minus P is at least 10, the sample proportion P hat follows normal distribution, would mean P and standard deviation square root of P 1 minus P over N. So here we use the z-score of the sample proportion as a test statistic. And we use the specified value P0. If we want to test the assumption that the null hypothesis say that P equal to P0, we assume that the null hypothesis is true. So when we assume that the null hypothesis is true, P is equal to P0, we can use P instead of P0 in the notation. So Z is P hat minus P0 over square root of P0, 1 minus P0 over N. Or when we assume X not is true, we have Z is P hat minus P over square root of P times 1 minus P over N. And just like z-test, the critical value method is based on the idea that we should reject the null hypothesis if the value of the test statistic is unusual, when we assume that the null hypothesis to be true. In this method, we choose a critical value, which form a boundary between the values that are considered unusual and the values that are not considered unusual. So the regions that contains unusual values is called the critical regions or rejection regions. And the region that contains the usual values is called the acceptation region. If the value of the test statistic is in the critical region, we reject the null hypothesis. And if we reject the null hypothesis after choosing a significance level alpha, we say that the result is statistically significant at a alpha level. We also say that the null hypothesis is rejected at the alpha level. And here's how we decide whether to reject or not reject the null hypothesis. Let alpha denote the chosen significance level. The critical value depends on whether the alternate hypothesis is left-tailed, right-tailed, or two-tailed. Suppose we have a left-tailed test, so we want the left-tail area to be alpha, and that is the area of the critical region. So we choose the critical values minus the alpha, which is a negative value. And the rule is if the test statistic falls into the critical regions, we reject the null hypothesis. So if z is less than minus z alpha, we reject the null hypothesis. If we have a right-tailed, we want the right-tail area to be alpha. So we choose the critical value z alpha because the area to its right is alpha and the area to its left is 1 minus alpha. The critical region in this case is the area to the right of z alpha. That means the left tail area right here, the shaded area. So if the test statistic falls into the shaded area here, the critical region, we reject the null hypothesis. So if z is greater or equal to z alpha, we reject the null hypothesis. For two-tail, we have the left tail and the right tail, and we want the total area to be alpha. And because normal distribution is symmetric, the curve of normal distribution is symmetric, so the area of its tail is alpha half. So we have two critical values. The left critical values is minus the alpha half, and the positive critical value is z alpha half. And the critical region is the two-tailed, the shaded area on the picture. So if the test statistic falls into the shaded area, we reject the null hypothesis. That means if z is less than minus z alpha half or z is greater than z alpha half, we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. And to perform a z-test by the critical value method, we should follow the following steps. First, we have to state the null and the alternate hypothesis. Step 2, we have to choose a significant level alpha and find the critical values. Step 3, we compute the test statistics. So z is p hat minus p naught over square root of p naught 1 minus p naught over n, or z is p hat minus p over square root of p 1 minus p over n, assuming that h naught is true. Step 4, we determine whether to reject the null hypothesis. If we have a left tail, if z is less than minus z alpha, we reject the null hypothesis. If we have a right tail, we reject the null hypothesis if z is greater or equal to z alpha. And for two-tail, we reject the null hypothesis if z is greater or equal to z alpha half or z is less than or equal to minus z alpha half. Basically, we reject the null hypothesis if the test statistic falls into the rejection region or the critical region. In step 5, we state the conclusion. So that was the idea of the critical value method. Now we go to the p-value method. The p-value method is to measure just how strong the evidence against the null hypothesis is. We compute a quantity called the p-value. The p-value is the probability that a number drawn from the distribution of a sample mean will be as extreme as or more extreme than our observed value of sample mean. The more extreme the value, the stronger is the evidence against the null hypothesis. The p-value is the probability, assuming that the null hypothesis is true, of observing a value of for the test statistic that is as extreme as or more extreme than the value actually observed. The smaller the p-value, the stronger the evidence against the null hypothesis. So if we have a left tail, we draw the standard normal curve and we mark the test statistics on the picture. For the left tail test, the p-value is the area to the left of z. So that is the area of this shaded area. For the right tail, we also draw the standard normal curve and we mark the test statistics. The p-value is the area to z, to the right of z's. And for two-tailed, we mark two test statistics. If z is negative, we mark z and they're positive. If z is positive, we mark z and is negative. And we have two-tail area here. The p-value is the area of these two areas, and because the curve is symmetric, so these two areas are the same, are equal. So we kind of take 2 times with the areas of the left tail or 2 times with the area of the right tail. And the procedure to perform a one proportion z-test by the p-value method is: first we state the null and the alternate hypothesis, then we choose a significance level, we compute the test statistics, then we compute the p-value of the test statistics. If we have a left tail, the p-value is the probability that z less than z. The right tail, p-value is the probability that z is greater than little z. And for two-tail, we either add the area of the left with the right, or we take 2 times with area of the right tail or 2 times with the area of the left tail. And here capital Z represents for a random variable that follows standard normal distribution, and little z here is the test statistics. Finally, if the p-value is less than alpha level, we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. So that's how the procedure to perform a one proportion z-test by now using let's go over an example. Method. In a recent Gen X2Z American college student survey, 90% of female college students rated the social network site Facebook as cool. Assume that the survey was based on a random sample of 500 students. A marketing executive at Facebook went to advertise the site with a slogan: more than 85% of female college students think that Facebook is cool. Can you conclude that the proportion of female college students who think Facebook is cool is greater than 0.85? Use the alpha level 0.05. Here we have two assumptions to be verified. First, NP is 500 times 0.9, which is 450, and n times 1 minus p is 500 times 0.1, which is 50. So since these two assumptions are met, the central limit theorem for simple proportion is applicable. So we can use a standard normal curve to test this population proportion. And let's summarize the question. Here, 90% of female college students rated the social networks as Facebook as cool. And this number comes from a sample of 500 students. So 90% is the sample proportion and 500 is the sample size. And the statement is more than 85% of female college students think Facebook is cool. So the specified values here is 0.85. So P naught is 0.85, and we have two possibilities. More than 85% of female college students think Facebook is cool, and at most 85% of female college students think Facebook is cool. So we have two hypotheses. P is equal to 0.85 or P is greater than 0.85. So this is a right-tail test. So now we have summarized the question. And no matter what methods you use, the critical value method or the p-value methods, you need to compute the test statistics. Here z is 3.13. You take 0.90 subtract 0.85 divided by square root of 0.85 times 0.15 over 500 using the formula of the test statistics. By the critical value method, we want the right tail area to be 0.05. So the critical value is z.05, which is 1.64. And on the picture, we make the standard normal curve. We mark z alpha. So the critical region is the area to the right of z alpha. If the test statistic falls into this shaded area, that means the critical region, we reject the null hypothesis. And here 3.13, the test statistic does falls into the critical region. So we reject the null hypothesis. By the p-value methods, we find the area to the right of 3.13. And we see it should be 0.0009. So we reject the null hypothesis. Therefore, there is sufficient evidence to conclude that more than 85% of female college students think that Facebook is cool. That is everything of today. Thank you so much for watching my video. I hope you enjoyed my video, and see you next time. Bye.